Now, let's have this remark. Shey dey feel me? Let's have this remark. If let f a function acting on the closed interval, which maps to R, be bounded on AB, then both the lower and upper Riemann sum are also bounded. Now, let's prove this. Proof. You know, for a function to be bounded, or if you want to say something is bounded, it must be between an interval of something like this. That means that x, you can say x is bounded between this interval. Do you understand? X is bounded. Now, the upper and lower Riemann sum, since f is bounded on AB, then there will exist real numbers. Are you with me? Real numbers, small m and m, such that now what I'm trying to do here is to show you guys that f is bounded. That is, f will be in between m, capital small m and m. That is like this. On what? On AB. Also, if f is bounded on this interval, f will also be bounded on the sub-interval. So, since f is bounded on AB, this implies that f is also bounded on the sub-interval, or the sub-interval of AB. Now, what is the sub-interval? Let's have the sub-interval to be xi minus 1, xi. Now, this is the sub-interval. Then there exists a real number mi and mi, such that, look at it, I want to do something here. Mi is less or equals to f less or equals to mi. Now, look at, let's have this number line. This is our m, which f is bounded. You now have mi, that is the sub-interval. We can see clearly that m is smaller than mi, and mi is smaller than capital Mi, and capital Mi is smaller than what? M. So I can write it as m less or equals to mi, less or equals to mi, like this. Do you get it? Now, let's multiply through above the inequality, introducing change in xi. And you know, change in xi, working on this interval, it can be b minus a. You understand? So let's introduce this. That is, you are going to have m delta xi less or equals to mi delta what? Delta what? Xi less or equals to mi delta xi less or equals to m delta xi. Do you get it? Now, introducing sum too. Introducing sum I equals to 1 to n. You are going to have, you know, this, I can bring this m outside since there is no I here. So I can have delta xi, I equals to 1 to n. Now, less or equals to mi, this one with summation I equals to 1 to n, mi delta xi. Abi, less or equals to summation I equals to 1 to n mi delta xi less or equals to. Now, there's no I here, so you can just have the m outside. I equals to 1 to n delta xi. Now, look at this expression I gave earlier. Don't let us use this expression. Now, look at this. Let me talk on this. On this, I equals to 1 to n. Abi? They say, for example, if you have this kind of line now, this is your this is your starting point. Abi? This is 1, 0, 1, 2, 3, 4. Abi? And you say, this one, we know that the distance from here to here is what? 1. Distance from here to here is what? 1 also. Distance from here to here is what? 1. Distance from here to here is what? 1. Now, if you now sum all the distance, let's sum it. 1 plus 1, 2. 2 plus 1, 3. 3 plus 1, 4. Abi? Let's now calculate the distance from here to here. This one we sum all the distance that we look for, which is equals to 4. Now let's look for the distance between this endpoint and this endpoint, which is what? 4 minus what? 0, which is also what? 4. Do you get it? Indirectly, I can say summation I equals to 1 to n delta xi is equals to what? B minus what? A. Do you get it? So here now, and recall that our lower sum, Riemann sum, is equals to I equals to 1 to n mi delta what? Xi. Are you with me? So, and upper sum UPF is equals to summation I equals to 1 to n mi delta what? Xi. Now, let's come back to this equation and let's modify it now. It will be m into bracket. This one, as I've explained, is what? B minus A less or equals to. Now this one is what? Our lower LP of what? F. And this one is our what? UP of F. And this one is what? M what? B minus what? A, because we have it here. Now look at, I can write this. Look at this. Since this is bounded, we can say easily from here, because they are both bounded. This is between an interval. This is also between an what? Interval. We can say that the upper and lower Riemann sum are what? Bounded. Because you understand the definition of this now. For it to be bounded, as I explained earlier, from here, look at it. Do you understand it? Now, from here, from where we stopped here now, from here, hereby we have MB minus A less or equals to LP, that is lower sum, and UP less or equals to B minus A. Now, introducing infimum. From here, wait, don't let us introduce infimum here. From here, I can say, we can just say this. Do you agree? I can say this. From here, is this one not less or equals to this? It's true. So I can pick it. Now, introducing supremum now. Introducing supremum. If you put supremum of a number is what? The number. So supremum of this will still be what? MB of A. Now, supremum of our and supremum of this will also be what? Abi? Now look at, and we have a definition for this. Our lower Riemann integral which is this, is equals to supremum of what? Of the lower sum for every partition in what? P. Abi, then we can see clearly that our lower Riemann integral is also what? Bounded. Can you see it? It's also bounded. Now look here too. Let's pick from this side here. I can drag to this point whereby we can pick MBA less or equals to UPF. That is the upper Riemann sum. Introducing infimum. Now, if we put infimum of a constant is what? A constant. So why is it a constant? So it's the one that we have the high number of itself. So let's put this now. Infimum, we are still going to have what we have here. Infimum of UP of F is a definition we know. You can see. Yeah, this one, it is bounded. Lower Riemann integral is bounded. Riemann lower Riemann integral is what? Bounded. You get? Here now, we know by definition that a b bar f of x dx is equals to integral is equals to infimum of what? Our infimum of our do you get this? Don't mind me, sorry. Now this one, you can see we have it here. So, and this is our upper Riemann integral. So this is telling us that our upper Riemann integral is also bounded. This implies that upper Riemann integral is also what? Bounded. Thank you. Hope you grab. Very simple. Thank you.